Hello everyone. In today's session, we are going to deal with the free marks. How you can get many marks from this chapter. The chapter name is Chemical and Ionic Equilibrium. Seems like a big one, but it is not. Trust me, it is not. Today, we are going to deal with weightage of the concepts, how many questions we can expect from this chapter, and we are going to do the entire chapter revision in simple words, in catchy formulas and tips and tricks, and followed by your favorite, my favorite, solving previous year questions with anticipated questions also. Without any further delay, let's get started. The weightage of this chapter is, for JEE main, we can easily expect 3 to 4 questions from this chapter alone because it involves chemical and as well as ionic equilibrium. In case of JEE advanced, you can expect 6 to 8 or 12 marks also from this chapter. The main topic distribution will be mostly they will be asking questions from ionic equilibrium rather than chemical equilibrium because it covers only few topics. Le Chatelier principle, that is a major topic, or you can expect a question as equilibrium constant, that is from chemical equilibrium. In case of ionic equilibrium, we have many formulas. So let's start our revision. The first, we have to know what are reversible and irreversible reactions. What are those? Reversible reactions are the one which can go forward and as well as backward. Irreversible one are the one which can go by one direction. It's like a one-way traffic. Okay, only it will give you the products, not the reactants. In this chapter, we are particularly concerned about reversible reactions. They are denoted by the symbol equilibrium, like this. Okay, so reversible reactions, you can find it out by this symbol itself. Okay, so if a reaction is maintaining an equilibrium, which means that it can go to forward direction and it can go to backward direction. So at equilibrium point, both the reactant side and the product side, there will be some kind of balance is going on over there, like a seesaw in the playground, right? So at that position, rate of forward reaction, which is equal to rate of backward reaction. And these reactions are dynamic. It changes very often, depend on the nature, atmosphere, and in atmosphere in the sense like temperature condition, pressure conditions, and addition of catalyst, addition of inert gases, how it changes its equilibrium, how it goes backward and forward. We are going to discuss that. Okay, so let's get into some interesting stuff about equilibrium and then we'll move on to the factors affecting equilibrium. Okay, first of all, there is a law of chemical equilibrium which talks about the equilibrium constant. What is equilibrium constant? What it says about? It is saying if a reaction is maintaining an equilibrium, how we can find whether it is going forward or whether it is going backward. Okay, so for that we do have a constant value, that is Kc, in terms of concentration. Kc means in terms of concentration. So concentration, let's say this is a reaction I'm going to take. A moles of A reacting with B moles of B gives, that is in equilibrium, X moles of X and Y moles of Y. Okay, so how will you write your Kc? It is just a products raised to the power of its moles. I mean the reaction coefficient divided by the reactant raised to the power of its moles. Okay, so why we need to know about this? What is the importance of knowing the Kc or any equilibrium constant? Because if the equilibrium constant is more than 1, then it says, the law of equilibrium says, the products are favored. It goes forward direction. If an K value is less than 1, then the reaction favored in the backward direction. Okay, the more of reactants will be formed. What if it is not less than 1, it is not more than 1, it's particularly after 1. Then equal amounts of products and the reactants are formed. Okay, so that is what we have to know, the Kc value, to find out which direction it is favoring. Okay, so how will that get changed? What are the factors are changes the equilibrium constant? You can expect question from this part. You can see more of these type of questions in your previous year paper. You can take, the question will be look like, this is the reaction happens. What if I'm doubling the amount of reactant? What will happen to equilibrium constant? What will happen to Kc? This is the reaction taking place. What if I'm dividing the product moles? Dividing it by 2, dividing it by 4. What will you expect? How it changes the equilibrium constant? That type of question, I'm sure you must be encountered while you are revising the previous year question paper. Okay, that answer lies here. So please be careful, please take a screenshot or note it down somewhere, write it down, and to get immersed in these equations and formulas. This will give you free marks. Okay, the first condition is that the temperature, of course, is dependent, but not a concentration independent. Okay, it is a temperature dependent. It's not but concentration independent. It's not depending on the concentration, but it do depend on the temperature. And it is independent of the catalyst. Some students get confused in case of catalyst. Catalyst is just a reagent which speed up the process. He is a guy nothing to do with product formation or nothing to do with the reactant formation. It's just there as an audience to see or encourage the participants in the game to move forward. Okay, imagine catalyst as a audience, the encouraging audience to promote the reaction. Okay, he will not do anything, he will not participate in the game also. Okay, then the third point, important point, is that depends on the stoichiometry of the reactant and the products. How, ma'am? Yes, I'm coming to that point. What are the cases? Here I have 4-5 cases. Take a look at it. First, what if I'm reversing the reaction? Let's say I'm giving you the reaction A plus B gives C plus D. They are saying K value is 1.1 into 10 to the power 1, 10 to the power 10. Okay, so what if the reaction is going backward? Find out the K value. Then you have to do one thing, just to do the reversal, just get it inverse. If they are saying 1 by 1.1 into 10 to the power minus 1, then do it like 1 by 1.1 into 10 to the power minus 10. Okay, as simple as that. That is first scenario, first type of question. The second type of question can be asked is that if an equation is getting divided by the factor n, let's say I'm taking a molecule, I'm dividing it by 2. Okay, then how will you find how it affects the equilibrium constant? What you have to do is, Let's say I'm taking a same example. The question is that I'm dividing the factor by 2. Then you have to do it square root of the value given. If they are saying 4, then that would be fourth root of the value given. Okay, so just to take the root of it. Then what if they are saying multiplied? Then it's just an opposite, right? What will you do? Do the powers. If they are saying 2, that is the equilibrium constant. If they are multiplying the reactant concentration by 2, then the K value will be 2 to the power 2. You will get 4. Okay. If there is a multi-step reaction, do the multiplication of each and every K equilibrium constant value to get overall equilibrium constant. It is the product of the individual step. Okay, so I'm keeping it here. Just take a screenshot of it. That will be helpful to you. Okay, done. Let's move on. Let's think about how the effect of temperature handles. It is denoted by the equation of Van Hoff equation. This will also can also be asked as a question. There are 2 equilibrium constants given. This temperature, find out the delta H value. That can be asked. Okay, or else they will be giving the temperature and delta H value. They will be asking you to find the log K2 by K1. So this equation is very, very, very important. So here delta H, that is enthalpy. Enthalpy means the energy, heat energy, right? So for endothermic reaction, enthalpy becomes positive, and for exothermic reaction, enthalpy becomes negative. Correct? So we have discussed these parts in thermodynamics as well. That is what enthalpy is, and then talking about temperature T1 and T2, that they will give the numerator is T2 minus T1 and the denominator is T1 into T2. Okay, cool. Sometimes they will ask the second temperature also, the first temperature also. Okay, so please be careful with this. And the important point over here is K value increases with temperature in case of endothermic reaction, and K value decreases with temperature in case of exothermic reaction, heat releases reaction. Why that is happening so? Who defines that? Our favorite Le Chatelier. What he says about equilibrium reaction? We can't say Le Chatelier principle without equilibrium, right? Because he is defining the equilibrium principles, how it proceeds. He just said, if I am disturbing any side of the equilibrium, it automatically get adjusted. If I am adding more reactant to the reaction, then it will give more products to make it equilibrium, to make it equal. Okay, if I am adding more product to it, then again it will go backward to form the reactant to make it equal. It's like a maintaining the weight in the balance. Okay, it's like a seesaw game in your playground. So that's what he explains. If we are disturbing the equilibrium, it will automatically get adjusted, get reacted in the way to come back to the original state. What are the factors may affect the equilibrium? First thing first, concentration. Increase in the reactant concentration, what will happen? I told you, it will produce more product. More product means what will happen? The reactant will get decreased, right? That's why it is giving more product. So increase in the reactant concentration will shift the forward direction towards the formation of product. And what if I'm increasing the product? Then it shifts backward to form more reactant. That is about concentration. Let's say I am increasing or decreasing the temperature. What will happen? So increase in temperature. Let's say that is an endothermic reaction. Endothermic reaction means heat absorbs. It is absorbing heat to do the reaction itself. In that case, if I am increasing the temperature, what will happen? Let's say you want heat to cook your food. I am giving you heat. What will happen? You will cook the food easily, right? So it will favor the forward direction. In case of endothermic reaction. What if I am having an exothermic reaction? You don't want heat to cook your food, but still I am giving you heat. What will happen? You will not cook. It will affect you. You will do the backward thing. Right? The same scenario happens here as well. And exothermic means heat releases. The consisting heat also it is trying to push outside. Why will that need the heat? Okay. So if I am increasing the temperature in case of, I am writing here clearly. So temperature condition means there are two possibilities. Temperature increases. In case of endothermic reaction, it leads to forward direction. If temperature decreases, backward direction. Similarly, if there is an exothermic reaction, heat evolves, heat releases, temperature increases, then backward, temperature decreases, then forward reaction happens. Okay, clear? Then the third important factor, that is pressure. What if I am increasing the pressure? We know the general formula PV is equal to nRT. Right? How pressure is related to moles? It is directly proportional. Right? What if I am increasing the pressure in the reaction container? What will happen? The moles will get, the volume will get decreased so that the particles will feel more pressure and then they can't breathe also. Right? For example, I'm saying, imagine it like this. So I'm applying more pressure means they can't breathe. So what they'll do? They'll balance it in the way to shift towards the fewer number of moles. Let's say in the reactant side, I'm having, I'm giving you the example of the famous process, Haber's process. N2 plus H2 gives NH3. Balance it, 2, NH3, 3, H2. Okay. So in this case, I am increasing the pressure. I am talking about in this case. You can apply that to different cases as well. So in this case, I am applying pressure. Applying pressure means molecules can't breathe. So what that will do? It will go the direction where they can do the less population. So here I am having 4 moles. This side I am having 2 moles. 1 plus 3, 4 moles. This side I am having 2 moles. So what that will do? it will push the forward direction, fewer number of molecules or less number of molecules, okay, fewer moles of gas, so that it will push the forward direction, so that less molecules will be there, so that they can breathe. Okay, so what if I am decreasing the pressure? It will do the backward process to get more number of moles of molecules. Okay, so pressure increases means, imagine a situation you are having you are in the room of 10 people. If the room's size becomes smaller means you can't breathe, so you will make in the way less number of people are there in the room. Okay, so that is what the same thing happens in equilibrium also. Most of the students do mistake in this part, that's why I'm stressing it a lot. Okay, then as usual, catalyst addition and inert gas addition have no effect on equilibrium. Kindly note it down. So you can take a screenshot of it. Let me move on to the next part. Now the next part is reaction quotient. Reaction quotient is mentioned by the symbol Q. It's not same to Kc. It's not similar to Kc. But what is the relation between the reaction quotient and the Kc is that if both the values are equal means, then we can say the system is at equilibrium. For Kc, you can see the formula is number of moles, concentration of the product raised to the power of products and reactants raised to the power of its coefficient. Here it deals with again product by reactant raised to the power of its coefficient. Okay, if both the values are same, then the system is at equilibrium. If Kc is greater than reaction quotient, then it proceeds forward direction. If Q value is greater than Kc, then the reaction becomes backward direction. The question can be asked in this way also. Okay, if I'm not wrong, 2016 the question was asked in this part, what is the Q value, what direction it reaction process. Okay, then here comes the Gibbs free energy, important relation to check that is in equilibrium or not, because we know that at delta G, delta S, if that is equal to 0 means that is at equilibrium part, right? So if delta G equal to 0, it means that is in equilibrium. Q is equal to Kc means that is in equilibrium. How to find delta G? Delta G is equal to delta G naught plus RT ln Q. Q you can find it by the above mentioned formula. Another way you can see using Kc also, that is 1/2 isotherm formula. So you can take a note of these three formulas which is dealing with thermodynamics and this chapter. Okay, so now we talked everything about how the reaction equilibrium works. Now it's time to talk about how the ions are working on it. What are the factors affecting it? How we can find what is ionic equilibrium and how the ions are maintaining its equilibrium position. Okay, the first thing first, common ion effect. It plays a major role for finding the equilibrium. Okay, so why I'm stressing this much? Most of the students, if I'm asking about a common ion effect, they will say commonly ion will be there. What that will do? Don't know. So it is just doing the suppression of ionization. I'm giving you an example. Okay. Let's say I'm having acetic acid. I'm having acetic acid, which is a weak acid or strong acid. It is a weak acid. Weak acid meaning it dissociates less. The ions dissociation will be very, very less. Right. So, which is also called as weak electrolyte. Okay, the number of H plus ions produced out of acetic acid is less. That's why that is weak acid. So, weak acid dissociation is more suppressed in the presence of common ion. That common ion may be a strong electrolyte. Let's say I'm adding HCl to it. Let's say I'm adding HCl to it. So what will happen? CH3COOH will get dissociated as CH3COO minus H plus. HCl can easily be dissociated as H plus and Cl minus. So in the solution, I am having more of H plus ions. This is common ion. Okay, this is common ion. So because of more of H plus ion, already acetic acid doesn't want to separate, doesn't want to become an ion. It's doing it because of the fate only. Okay, so still if there is a chance to not to form an ion, means it will take up the chance. It will use that opportunity, right? So the dissociation will get suppressed because of the common ion. That is called common ion effect. Okay, it decreases, it suppresses the ionization of the weak electrolyte. Okay. It follows Le Chatelier principle, and the points to be noted here is that that decreases the solubility of a sparingly soluble salt, that is weak electrolyte, weak base or weak acid. And the important application is that it is used in case of buffer solution. We are using common ion effect in buffer solutions. What is buffer? We'll see. We talked about these applications. We'll see about the buffer solution. Before that, I would like to tell you degree of dissociation. Dissociation, as I told you, how many ions are formed, right? How much it is getting dissociated. Degree of dissociation means degree is just an evaluation of paper evaluation, right? Similarly, how much ions are getting dissociated. That is what degree of dissociation is. Let's say total number of molecules present in the solution. Out of that, this many molecules are getting dissociated. Total I am having 50 molecules. Out of that, 25 is getting dissociated. Means 50% molecules are, 50% is the degree of dissociation. Alpha value, that is 50%. Okay. So degree of dissociation is greater than equal to 0 but less than equal to 1. 1 is the maximum number, right? So 100% is a maximum percentage. You can't get 101, 100 and 200, right? So in case of strong electrolytes, it's more or less 0 because it can easily get dissociated. In case of weak electrolytes, it will be less than 1. What it depends on? It depends on the concentration, it depends on the temperature. More importantly, it depends on the common ion. It depends on the solvent, how much it is getting dissociated. All these factors affects the degree of dissociation. You can expect a question using this formula also. calculate degree of dissociation for the given weak acid and weak base? I told you this is for especially for weak electrolytes. Weak electrolytes includes weak acid as well as weak base. Right? Weak acid like acetic acid or organic acids or weak acids, and weak base includes ammonium hydroxide. Okay, so those are how will you find your degree of dissociation of these acids means you have to find Ka value divided by its concentration. Square root of Ka divided by its concentration for its dilute solution. Dilute solution means we are adding more water to it to make it dilute. So if I am increasing the concentration, what will happen? The alpha value dissociation will get decreased, and if I am increasing the temperature, the ion's movement will be high, so it will dissociate a lot. Common ion is there means it suppresses, so alpha value will get decreased. That's what the Ostwald's dilution law talks about. It is talking about degree of dissociation of the weak electrolyte increases with dilution. If I am adding more and more water to it means that dissociation will get increased. That's what he is talking. That is Ka which is equal to C concentration alpha degree of dissociation alpha square by 1 minus alpha. Huge derivation was there in the book, so we are not concerned about the derivation part for now because we are going to do 1 mark questions, I mean MCQs and FIBs, right? So this formula is important. What are the special cases in talks about this kind of dissociation is that we have told for very weak electrolytes it's less than 1, obvious. Very weak electrolytes is far less than 1. So the Ka we can just omit this value because that is a very small value, it's less than 1. Then it will become C alpha square by 1. So overall that will become C alpha square only for very weak electrolyte. In case of moderate dilution, what will happen? The alpha degree of dissociation will be equal to root of Ke by C. These formulas are important. Now, having these knowledge about how the equilibrium works, we are diving into ionic equilibrium. So talking about ions, I should have tell you before, but talking about ions, we must know about what are strong acid, what are weak acids, what the scientists told about these things, right? So there are 3 types of theories for strong acid and weak acids. So first theory talks about H plus producers in aqueous solution are acid. It's said by Arrhenius. The question can be asked in the way, which of the following is Arrhenius acid? Which of the following is Arrhenius base? Similarly, which of the following is Lowry-Bronsted base? Which of the following is Lewis acid, Lewis base? So questions can be asked in this part. Please be careful. So we have to know what these scientists said about acid and bases. The first thing, Arrhenius, he is talking about H plus donors, H plus producers are acid and OH minus producers are bases when it is in aqua solution. Then Lowry-Bronsted or Bronsted-Lowry, they are talking about proton donors are acids, proton acceptors are bases. It should have a ability to accept the proton. Proton is H plus. Okay, so they are called bases. For example, here you can see ammonia. Proton, that is H plus, So it can accept the proton to form ammonium. So according to Lowry-Bronsted, ammonia is a base. Finally, Lewis is talking about electron pair acceptor. Here the twist is there. Electron pair acceptor means what? It should have a vacant orbital, isn't it? So for example, here I am talking about BF3. It should have a vacant orbital to accept the electron pair. What is vacant orbital? I am giving you the example for BF3. You can work on AlCl3. Boron, how many electrons it is having? 1s2, 2s2, 2p, 1. Atomic number is 5. So if I am writing 2s2 and 2p1, how it accommodates the 3 fluorines upon excited state? These jumps towards here. It makes the accommodation for incoming fluorine. So fluorine attached over here. Right. This is what the vacancy or valency is talking about. So 3 fluorines occupied. Remaining 1, this is vacant now. This vacancy can be fulfilled by the electron pair. That's what he is talking about. The electron pair acceptors are acids. Similarly, you can try it out for aluminum chloride. Here, electron pair donors are bases. Ammonia, that is having lone pair. H2O, oxygen is having lone pair. F minus, fluorine is having lone pair. So electron pair donors are bases. Okay. Fine. Let's move on. Next topic is salt hydrolysis. What is salt? Salt is something like it's neither acid nor basic. It's a neutral thing, right? So how do I do hydrolysis? Hydrolysis means separation. Lysis means cutting. Hydrolysis means by water it is just separating it. So weak acid plus strong base. The salt is formed by weak acid plus strong base. Say for example, weak acid, acetic acid plus strong base, NaOH. The salt formed is, don't say CH3COOH, paracid and all. So the salt formed is sodium acetate plus water. It is undergoing anion hydrolysis and the pH is more than 7, that is alkaline, because you can see I'm adding strong base to it. So the pH becomes alkaline and KH you can find it using Kw by Ka. So ionic product of water and those stuffs you already know. Then strong acid plus weak base. Strong acid, let's say I'm taking HCl. Weak base, ammonium hydroxide. The acid, the salt produced is ammonium chloride plus H2O. Right? So it is undergoing cation hydrolysis and it becomes acidic. You can remember it like, if I'm adding strong base, so the solution becomes alkaline. I'm adding strong acid, the solution becomes acidic. You can remember it like that. And here you can find the KH value, the hydrolysis constant value by Kw by Kb. What if both the scenarios are base? weak acid plus weak base. In that case, what will happen? CH3COOH plus ammonium hydroxide. Acetic acid plus ammonium hydroxide, it will give ammonium acetate plus water. Both the anions or cations, both are getting hydrolyzed, and the pH is 7 if Ka, which is equal to Kb. The KH value, you can find it out by Kw divided by Ka into Kb. Both the ions we have to take for consideration. Both the K values. Okay. So please note down these formulas. Now we are moving on to the another important and interesting part in ionic equilibrium, that is solubility product, KSP. What it defines? It is talking about how much of a solute can be dissolved in the solution or solvent. So we have different type of electrolytes like binary electrolyte or tertiary electrolyte or quaternary electrolyte or complex salts. You can take anything. So depend on the solubility value, molar solubility value, we will find the solubility product. Here small s stands for molar solubility. Question can be asked by giving molar solubility of an ion for asking KSP, solubility product value, or else they will give you solubility product and asking for S value. Molar solubility, the unit is mole per liter. Because it is molar, right? Mole per liter. Okay, so let me give you one example. Let me take a complex salt so that you can work on the simpler forms. Calcium phosphate. Calcium phosphate. So how it will get dissociated as? It will give you 3 calcium 2 plus ions plus 2 phosphate 3 minus. Right. So how will you find KSP for this? Solubility for product for this is, first you have to understand one thing. 1 mole of calcium phosphate gives 3 moles of calcium ion and 2 moles of phosphate ion. Okay, so here it goes as 3 moles of the solubility of calcium, that is S to the power 3 into 2 moles of the solubility of phosphate to the power 2. So 3 cube, that is 27, 3 into 3 into 3, 27 S cube into 4 S square. In total it will become 27 into 4, 108 S to the power 5. So the KSP of this kind of salts is 108 S to the power 5. And do we have to memorize all those things? Means you can go by this way, or else for the simpler molecules I have given you the formulas. For example, the binary electrolyte. It doesn't depend upon ions, charges. It doesn't depend upon the charges. It's just asking about what ratio in it. Here you can see AgCl, Ag 1 Ag plus and 1 Cl minus. Okay, BaSO4. Although the charges are 2 plus and 2 minus, here comes 1 Ba stands for 1 SO4. Okay, that is in 1:1 ratio. So you can find the KSP value by using the formula KSP is equal to S square. Similarly, for ternary electrolyte, 1:2 ratio or 2:1 ratio. In that case, KSP equal to 4S cube. Okay. For quaternary electrolyte, 1:3 ratio in case, that is 27 s to the power 4, and the complex salt what I have defined now, 3:2 ratio, that is 108 s to the power 5. So this is how we found the KSP values, how it is getting dissolved. Why that is so important means, higher the KSP means obviously the solubility is higher, and the precipitation occurs when the ion product is more than KSP. This can be asked. The KSP value is this much. So ionic product and KSP product is given, whether the precipitation happens or not. This kind of question can be asked. Please be careful. And common ion effect reduces the solubility, that we know, and the temperature generally increases the solubility and KSP values. This we know. Then we came to the last part of this chapter, that is buffer solutions. Buffer solution are the one which maintains the pH even if I am adding the small amount of acids and bases also. Okay, there are several types of buffer solutions. Let's see one by one. Simple buffer means weak acid plus weak base. That is the simplest buffer. Mixed buffers are there, acidic buffers. Here you can see the most of the questions can be asked from acidic and basic buffers. That is weak acid plus its salt. For example, if I am taking weak acid as acetic acid, its salt, sodium acetate, that combines to form a buffer. Basic buffer, weak base and its salt, ammonium hydroxide, its salt can be of sodium ammonium acetate. Okay, so that is weak basic buffers. Where the numericals part come from is that Henderson equations. Henderson equation, he gave the equation to determine the pH or the pOH. Sometimes they will give you the values of base and asking you to find the pH. Then you have to apply the formula pH plus pOH gives 40 equal to 14 to find the corresponding pH or pOH what examiner is asking. So these equations are important. Then buffering capacity. Buffer capacity is that, let's say I'm having a buffer, I'm adding acid or base. I told you buffer will maintain its pH. How much ever it can resist. At one point of time it should show the real pH, right? So the resistance of the buffer is called their buffer capacity. Mathematically, it can be expressed in delta N by delta pH. So the change in pH and delta N is moles of acid or bases added. How much you are adding? What is the change that is showing? What are the factors that affects the buffer capacity is the concentration of buffer components. Higher concentration means that will have a higher capacity, and relative concentration of acid and bases and salt. So the concentration of whatever the acid you are adding, base you are adding, that will also affect. So buffering capacity will be high at when pH is equal to pKa. Okay. So these are the formulas, these are the important parts of this chapter. It's time to solve some problems. Let's solve each problem one by one. If you are too Let's solve this each problem one by one. These are some previous year questions and the questions we can anticipate this year. The first question is talking about at a given temperature, the equilibrium constant for the reaction N2O4 gives to NO2 is 0.0625. If the initial concentration of N2O4 is 2 molar and the initial concentration of NO2 is 0, calculate the equilibrium concentration of NO2. Okay, so how will you find? Just to write the equation for this type of question, I would recommend you to, while practicing itself, write the equation and write the concentration given. Okay, so the initial concentration of N2O4 is 2 molar and 0. Now we have to find the equilibrium concentration of NO2. Equilibrium. At equilibrium, what would be that concentration? So tell me one thing. At equilibrium, what happens? If the reaction start happening means some amount of N2O4 will get converted to NO2. Right? So let's say I'm taking that amount as X. So 2 minus X will be formed as at equilibrium state. It is initial, it is at equilibrium. And what will happen to NO2? The 2X will be formed as NO2. The reactant will give you the products. The Kc value they have given. So just try to substitute these things in the Kc equation. It is talking about the reactant divided by product divided by the reactant concentration, raise it to the power of its moles or coefficients, which is given 0.0625. So NO2 2x to the power 2 N2O4, that is 2 minus x, which is equal to 25. So here upon solving, what will you get? You will get the x value. So 4x by 2 minus x you will get, and from the equation automatically you will get the x value as 0.5 molar. Okay, is it clear? If that is not clear, please let me know. Then the correct option to this question is option A. Let's move on to the second question. Let's quickly solve. pH of a 0.1 molar acetic acid solution is 2.87. Calculate the ionization constant Ka of acetic acid. So pH given, that is 2.87. They are asking for Ka. For Ka, what is the equation? So for finding Ka, first of all, how acetic acid will get dissociate? Acetate ion plus H plus. So Ka, which is H plus concentration, acetate ion concentration divided by ionic concentration, overall concentration of acetic acid. Okay, so now we want H plus concentration, right? So how will you find H plus concentration? So from the given pH, just pH, which is equal to minus logarithm of base 10 of H plus concentration. So 2 the reversal, so that you will find the H plus value as 1.35 into 10 to the power minus 3. which is equal to our same CH3COO minus ion concentration. It is 1.35 into 10 to the power minus 3. So what you can do substitute these values over there. I'm just giving it square because concentration of both the ions is same, divided by the concentration of acetic acid, that is 0.1 molar, that is given in the question. So you will be ended up with 1.8 into 10 to the power minus 5. That is your Ka value. Now let's move on to the next question. The question is asking for the reaction PCl5 gives PCl3 plus Cl2, Kp, that is 1.8 atm at 250 degrees Celsius. If the partial pressure of PCl5 at equilibrium is 0.5 atm, what is the partial pressure of Cl2? Okay, so Kp, we didn't talk about Kp while revising the chapter. What is Kp? Nothing but in terms of pressure. Equilibrium constant in terms of pressure. So for example, Kp, in case of Kc, we wrote it the product concentration by reactant concentration. Similarly, here also you can write the product concentration, product partial pressure by the reactant partial pressure. As simple as that. Okay, if the reaction is A plus B gives C plus D. Here the reaction is PCl5 giving PCl3 and Cl2. So how we can solve this problem? Just I'm going to write the Kp for this. Partial pressure of PCl3 into partial pressure of Cl2 divided by partial pressure of PCl5. So Kp value they have given, that is 1.8, and at equilibrium PCl5 value, PCl5 partial pressure is that 0.5. So I'm taking 0.5. What about PCl3 and Cl2? I'm going to take that as X. Both are at equilibrium state only, right? So both the values will be same. So X square by 0.5 equal to 1.8. So X square will be 0.9 and X will be 0.95. So this is for Kp related problem. Then the fourth problem is calculate the pH of the buffer solution prepared by mixing 0.2 molar ammonium chloride and 0.1 molar ammonium hydroxide. Given Kb for base. For ammonium hydroxide is 1.8 into 10 to the power minus 5. So this simple equation you can apply, that is POH which is equal to minus log base 10 OH minus concentration, isn't it? So also we know that POH which is equal to minus log of Kb into concentration of this base divided by ammonium, correct? So in this case you can just substitute the values. Log of Kb value is given 1.8 into 10 to the power minus 5. Ammonium hydroxide concentration is 0.1. Ammonium concentration, you can take it from ammonium chloride, that is 0.2. I'm taking ammonium as ammonium chloride salt only, so you can take ammonium chloride also, no problem. So the formula is Kb into base divided by the salt, right? So just substitute the values, find out the final answer. They're asking for pH. I told you, right? Sometimes they will give you the base details and asking for the pH. So in that case, you have to use the formula pH plus pOH equal to 14. So pH we don't know, but pOH is 5.26. So pH will become 8.74. You can see 5.26 is also in the option. Mostly that will be there in the option. So you should be careful. 8.74. Then next question. Solubility product of AgCl is 10 to the power 1.8 into 10 to the power minus 10. Calculate the solubility in 0.1 molar of NaCl solution. So they have given very simple question. KSP of AgCl. So Ag plus and Cl minus, which is 1.8 into 10 to the power minus 10. They are asking the solubility, molar solubility of 0.1 molar NaCl. So the common ion for both the salt is Cl minus, right? So you can take the concentration of Cl minus ion, which is in NaCl, that is equal to the concentration of Cl minus. So that is 0.1 molar. Therefore, Ag plus concentration will becomes 1.8 into 10 to the power minus 10 divided by 0.1, which becomes 1.8 into 10 to the power minus 9 molar. into 10 to the power minus 9 molar. Let's move on to the next question. For the reaction N2 plus H2 gives ammonia, what is the relationship between Kp and Kc? This part. So this is very important. I missed to include in the formula. I'll include it in the formula sheet. Don't worry. So Kp-Kc relationship. So Kp, we talked about that. That is in case of partial pressures, and Kc, that is in terms of concentration. So the relationship between Kc and Kp for any reaction is that Kp, which is equal to Kc into RT to the power delta Ng. What is delta N? Delta N is moles of gaseous products. If there is more than one, then sum of moles of gaseous products minus moles of gaseous reactants. So for example, the typical example, A plus B gives C plus D means C plus D, that is a coefficient or moles of the reactant, product minus reactant, A plus B. Here you can take delta N value of N2 plus 3H2, that gives ammonia as 2 minus 1 plus 3, in total 2 minus 4 minus 2. So Kc will become RT to the power minus 2. So that is our answer. Next question. A solution contains both ammonium chloride and ammonium hydroxide. What happens to the pH when HCl is added? It is having ammonium chloride also, ammonium hydride also. So this is a buffer solution, isn't it? Weak base and its salt. Buffer solution. When HCl is added to it, when that is added, what will happen? H plus reacts with OH minus to form ammonium hydroxide. 1 second. Correct. So the equilibrium shift to maintain the ratio. Say for example, here I am having ammonium hydroxide. That will give you ammonium ion plus OH minus. In this solution, H2O will be. So H plus and OH minus ions, that will form H2O. So that OH will again react with ammonium to give ammonium hydroxide. So equilibrium shifts to the right to maintain the ratio. So what will happen to the pH? So pH will undergo a small change. So pH will decreases slightly because HCl is added to it. Lower the pH, more will be the acidity. Higher the pH, more will be the alkalinity. Then 8th question. The value of Kc for the reaction CO plus H2O gives CO2 plus H2 is 4. Kc is 4. Temperature is 300 Kelvin. If 2 moles of each of CO and H2O are mixed in a 1 liter vessel, volume that is 1 liter, what is the equilibrium concentration of CO2? Why they are giving this much information to find out the simple question? The only reason is to trick you. They are just asking the equilibrium concentration of CO2. We can just apply it in Kc formula. Let's do it. So CO plus H2O gives CO2 plus H2. Initial 2 moles of CO, 2 moles of H2O. Initial that is 0, 0. At equilibrium, I am taking it as 2 minus x, which will give you x and x. So let's apply that in the formula. Formula is, you very well know about that. I'm just writing it. H2O, which is giving x square divided by 2 minus x the whole square. So you can do the quadratic equations because you are good at math. So find out the x value. You will ended up getting it with 1.33 molar. If you find any variations in it from my calculation, please do let me know. Okay, the next question, that is KSP of magnesium hydroxide is this much. What is the pH of the saturated solution? What is the relationship between pH and KSP? That is so simple, guys. Don't miss out this type of question. We already know KSP question is very simple, right? So KSP of magnesium and OH minus, that is 2:1 format. So 4s3 cube. So 4s cube, that is the value of KSP. So S stands for solubility, right? So S stands for solubility means, then find the S value, which will comes out to be 1. Just substitute the S value for the concentration. Okay, the KSP is given. Find out the S value, which is 1.44 into 10 to the power minus 4. Okay, so once we found out the S value, here you can see OH minus. So from the equation we know that is S, this is 2s square. In total that becomes 4s cube, right? So OH minus, that is 2s, OH minus concentration is 2S. So 2S, which is equal to OH minus concentration, that is equal to 1.44 into 10 to the power minus 4. So if OH minus concentration I know, then POH will be minus log of 2.88 into 10 to the power minus 4. Sorry. So it will be 3.54. So POH is 3.54 means pH will be just subtracted from 14. You will be getting 10.32. Okay, so options will not be this much close. Don't worry about that. Then the next question. In which of the following cases will the equilibrium constant not change? Obviously, that is addition of catalyst. Okay, so this kind of free mark questions you can expect this year. Okay, so please do more and more practice on this chapter, which will help you to crack your examination with highest marks. Don't worry, you will rock it. Only one thing you just need to do is practice, because practice makes a man perfect. Thank you.